Okay, welcome to Kubernetes SIG Network Meeting on July 31. I don't know how to say it. Okay. We are under the code of conduct, so behave and be kind with the others, and we can start with triage. View tab. So are you seeing my screen or not?
We are seeing the triage list or the issues list.
Okay, now I need to put SIG Network. Okay.
You might also filter for needs triage.
How do you filter by that? Without this label?
Type needs.
Needs? I didn't know that exists. I always triage it. Okay. First one. Oh, okay. The nodes that are not ready, in which might have a node network unavailable condition, are added to the load balancer services. Okay. I was going back and forth with this with the person that opened the issue. So let me explain a bit what this is about. There is an F5 load balancer that when it adds a new backend, it by default sends traffic. The F5 recommendation is to, when you add a new node, add in disable state that after it warm up and start health checking, start to enable the node state. Okay. I know this is not the same issue, or it's the same issue with the other person. Okay, I was confusing the issue. This is a different one.
The last comments here look like it's a SIG cloud provider or cloud provider implementation. We've done a bunch of work around the node life cycle stuff with regard to the health checks. I'm not sure if they're using it.
But let me find the other one, because now I don't know if both are the same. Signal word. Okay, signal word.
But that issue sounds like the implementer of the load balancer service just handles this incorrectly.
That's exactly what I was saying. This I don't know now if this is the same issue, because both are related, and this is the one that I was mentioning. They have an F5. This is the discussion, and this is the summary I added in the bottom. The F5 add the node pools, that indicates, and so it's an implementation, a limitation problem. The cloud provider also has another limitations, and what they want to build is the service controller to do changes on labels and then build a new orchestration on top of these new behaviors with label changing. So I don't know if both are related. And to your point, Tim, is I'm adding this to SIG Network because the service load balancer for me is SIG Network. I mean, we did a lot of work, you and Alexander and everything, and I don't think that we need to allow people to stand on the behaviors and implement these labels and annotations and build on that. We had a lot of work in Gateway API to solve this problem. And well, I don't know if anybody wants to take a look to these two issues. It's about that. It's load balancers that.
I'm interested in it mostly from the point of view of we did a lot of work, and I thought we had most of the cases that we needed to cover covered. So if we're not covering some other case, I'm interested to understand why or what. And there's the whole like node lifecycle discussion going on, and this seems aligned with that. Like we've gone back and forth on whether node readiness is actually relevant to being used as a load balancer or not.
No, but then I remember one big outage because of this. It's the load balancer now health checks the data plane, right? The moment that you tie the load balancer health check to the node lifecycle. So what I'm trying to say is that the workloads can be alive. You can be forwarding traffic, but the node not be ready. And people depend on this, right? They say, oh, the node is not ready, but I still want my workload to work. My load balancer, if it's health checking, to send traffic, because I don't know, the control plane can go out. The moment that you send the control plane out, what happens? What is the state of the node?
That's right.
You have a network partition, right? So I know this because I've been in an internal escalation because of this. And at that point was, okay, it's not ideal, but it's safer to the data plane to just keep polling the workload directly and sending traffic, because at least if your control plane restart, reboot, or is unavailable or has a network partition, you are still serving. Does it make sense or doesn't
it makes sense to me. I think the other part of this is whether a node is unready because it's going out of service or whether a node is unready because it's coming into service, right? Like on the end of life for a node, we know that it's probably still okay for you to be forwarding traffic while connections are draining, but on the way up, you might not be ready yet. So I don't know what to do with this issue if we are still not clear enough in our various health check modes. And I'm not going to have time to follow up on this issue right now. So it would be great if we understood what it is rather than just saying not our problem or OpenStack cloud provider specific. Maybe it is, and maybe that's the real answer, but I don't want to ignore it.
Okay, so it needs more investigation. If anybody wants to get more information. Next one. Kube-proxy IP tables use interfaces addresses instead of nodes internal IPs on SNAT. This is a complex setup with routing two interfaces. It's using the common approach of putting the IP of the node in the loopback and use it as source for the communications. And services is a virtual route. And when they hit the services, the traffic that is outgoing is not using the source IP of the loopback as the user expects. I commented with him. He may try to make the system to select the IP that he wants when it's going to the service IP, and we are still discussing. But I don't think that it's a kube proxy problem. It's more a network configuration problem. And I also don't see if it's even using kube proxy.
I think Cilium says it's okay. Oops. Sorry, phone rang. I think Cilium says it's okay to use kube proxy, but maybe that's outdated information.
I remember at one point they have a Boolean or a tree state, and they moved to a Boolean or something. They just wanted to consider legacy, and I don't know. I would assign to myself, and we'll keep talking with this person. Maciek, this is one good for you. So you have a lot of knowledge in this area. Okay, moving on. This is fallback partial user space proxy. Okay, this came up also in Slack today with Maciek from SIG CLI. People use the trick of using node port localhost. Also, Maciek told me somebody may attend the meeting. So if he's in the meeting, please tell me. People use the node port localhost trick to put the local cache registries, because with that, are you Austin, the person?
Yep.
Okay,
Yep.
let me finish this and I hand it over to you. So they use this localhost trick and then they don't need to configure security because it's localhost. They can use insecure and they use this for cache the registries. With NF tables, Dan in IPv6 this doesn't work, and with NF tables, Dan say that we shouldn't implement it. And now this is the conversation that is reopening. Okay, I hand it over to you, Austin. You wanted to talk.
Yeah, I guess just to provide kind of some more context on the use case, and I actually didn't know about this issue. I'll definitely go take a look at that. But we do this in a project that I maintain called Zarf, where kind of the goal is to make the air-gapped Kubernetes experience easy. And one way we bootstrap the cluster is, like, we actually have a cluster running. We have a registry running in the cluster at 1.27.0.0.1. And so right now we have that on localhost node ports. NF tables became stable. IPv6, is slow, but it's becoming more common. And so we want a way for this to work more broadly. We can, and I'm experimenting right now, it seems to work relatively well. Use host port and host IP at 1.27. That makes it work with NF tables, but it doesn't make it work when someone blocks route localnet or blocks or IPv6, which just doesn't allow traffic from from ::1 localhost redirection. And so, yeah, looking to make this experience better. Happy to contribute or discuss more.
So are you using it? Is the use case involving non-TLS, like use insecure registry? I forget what the Docker flag was back then. Yeah. So like the reason we added localhost node ports in the user space kube proxy 10 years ago was exactly this use case, to run a proxy on every node. And it was acknowledged at the time that it was kind of a stinky model, but we didn't have a better answer. And now we have at least the idea of services with prefer same host or prefer same node, right? So in theory, could we shift this use case to prefer same node and just allow insecure registry for the service IP? It would be sort of like DNS, where you'd get a static IP for your registry and configure your runtime to use that IP for registry polls.
Interesting. I know. So I guess you would have to configure the CRI to say, like, this is insecure, where we have like a global config that can tell the CRI, hey, this service is okay, even if it's insecure.
Yeah, that's the pushback. I tell the same to Maciek CLI, and he told me the problem that they have is by default, if you use localhost, you don't need to Maciek is here. Okay, then
yeah,
I
here.
stopped.
Yeah. So in general, like you said, the major problem is that the local host does not force you to do additional configuration. If you try to use any other IP, whatever that will be, private or whatever else, you'll end up configuring whatever CRI you have, whether that's containerd, CRI, or anything else, to explicitly say that, oh, this particular IP can be used insecure, because we know and we are running this particular registry within this this cluster, but we would either have to inject the certs, and that will be like, for example, self-science certs for this particular registry, or we would have to modify all our nodes to be able to accept insecure registry from this particular IP. That's why the local host currently seems to be the least of a hassle, because you only rely on that, and no additional configuration is required. I will admit that I'm not 100% sure how the same how did you say same port works. I've never tried that one, so that's probably something that we could.
It's pretty brand new.
Yeah, but I'm worried
What
that
was that?
Prefer same node. Dan just added it like in 34, so it's brand new, or 33.
Yeah, but I'm worried that we will run into the IP configuration topic again.
Yeah, and I was about to say you can use DNS for this, but you really don't want to have your runtime relying on services to do DNS in order to pull images in order to serve DNS. Like you don't want that cyclical dependency. So there is an advantage to using localhost for this, and also using localhost guarantees you that you don't leave the node, so you don't travel, you don't have to do self-signed or anything. The problem is, as Dan cites in this issue, route localnet was a mistake. Like it's a pretty glaring hole that we then have to patch up with a miasma of IP tables rules to block other traffic.
Yeah. So, I mean, one thing that's interesting with like the host port solution is that if we're using a proxy, we can actually, use self-signed certificates and secure everything off the node, which is nice, and I think is actually a pretty good security posture. Nothing unencrypted leaves the node. But if you're using something that blocks the root localnet hack, you can't use host port because host port still has IP table rules that route the IP addresses to the pod. And so even if you have host IP, it's never actually leaving the node. Oh, sorry, go on.
No, but the host port API should work, right? Other thing is that the implementation doesn't work.
I believe, with IPv6.
Okay, I understand. Yeah, okay. Yeah. So that's the thing. We were relying on the implementation. Okay, so the question for Tim and the others is, do we expand the API to support everything? That means that people need to implement it with eBPF, user space, or whatever other technology.
So my feeling is with NF tables, all the issues with IPVS should be resolved by deleting IPVS. So the question is, can NF tables be made to do this without route localnet, or even with route localnet, but with the gross tangle of other IP tables rules? I don't like it, but that I think is the only answer.
We can. I will follow up. I will ask the NetFilter community this problem, because I work with the maintainers and then also work with some of them. I will follow up with Dan Winsip and ask if there is a canonical solution in the.
I would rather that we don't like fall back on user space proxying, or if we do, that gets a total rewrite, because it was really very low quality, the user space proxy that we had. I wrote it, so I can say that.
My question is, do we become an API, or will this become a right now it's a behavior people rely on, right? We can agree on that.
It does seem to be, and you and me and Dan and others went back and forth about whether it was really okay to break it or not, and it turns out the one use case that we identified is still actually important. So I was kind of hoping that you'd have a different use case so that we could at least say now we have two, but it's the same one.
Okay, I think that I will follow up with the Linux NetFilter community and try to see if I find a question. I'm going to drop here the triage and everything because we have two items that is going to take time, and I'm going to close here. And Marek tried to present this during two SIG Network meetings, so and then we have Maciek that will need between 15 and 30 minutes. So if we try to be fast here. So Marek, please go ahead and present your topic. Is Marek here?
Yes, I'm here. Hi, hey everyone. I cannot share a screen.
Tim, I don't have powers to. You cannot because you are not allowed, or you...
I made you co-host. Go ahead, Marek.
Okay. Okay, can you see it? Okay, so actually I came here with a CAP proposal, and this is needed to unblock the IPv6 adoption. Right now, all the major cloud providers have some API based on IPv4 that is called metadata service. So this is common for Google, for AWS, for Azure. All of them have metadata service available on a well-known IPv4 address 169.254. And actually, it makes workloads incompatible between different stack types. If we take the same workload and try to deploy it to the IPv6 only cluster, it will fail because it doesn't have IPv4 connectivity. That's why some providers have a domain name for this. So, for example, Google has metadata Google internal. I couldn't find the same domain name for the other cloud providers. The case is that this is usually used for the workloads bootstrap to get the service accounts, to get the privileges, the very important metadata that is needed right away. And if the workloads were to rely on the DNS server that still has to be started in the cluster, like core DNS, and only after that send some requests to upstream, and this introduced a lot of latency. And historically in Google, customers have problems with this in GKE. That's why in GKE, everyone right now is using this IP address. No one is using the domain name. So the proposal right now is to allow configure this IP address in pods etc host by providing something that we, let's say, call core hosts. So this will be like additional kubelet configuration flag that will point to a file managed by the cloud provider, and it will allow cloud provider to populate additional entries to the pods etc host. So it will make the most important core domains resolvable locally without need to communicate with the DNS server. So this doc has some more details on how we actually want to achieve this. What's important is that we will forbid defining IP addresses for the domains that are managed by kubelet itself. So actually every local host address and what's listed here. Other edge case is that we actually allow customers to override DNS name. So if we have DNS name pointed to some IP address and customer is using host aliases in pod specification, then it will override the kubelet setting. So we are keeping the same behavior right now, because if all addresses are resolvable remotely by DNS server and someone defines a host alias, it can override the IP address. And What's more, if customer defines additional domain name for the IP address already defined in the core host, we combine both of them. So this essentially will unlock us and probably all the providers to have workloads to not rely on the IP stack of the cluster. Yes, Tim.
So this seems consistent with how we handle ResolveConf, kind of. My question is, why not actually handle it the way we handle ResolveConf, which is take the host's ResolveConf and merge it with what the kubelet wants to configure, where merge is defined inside kubelet with some reasonable rules. It sounds like we could do the same here and just read the host's at the node's etc host file, merge in any lines that aren't localhost or hit special rules, and then, like you said, do the overrides. That's a good consideration.
Yes,
and
but it would be like the same if you provide etc host here.
Yes. So in fact, the way ResolveConf is implemented is there's a flag that says, go read this ResolveConf. This is the host ResolveConf, and it defaults to etc ResolveConf, but you can point it to any other file you want.
Okay. I believe this will also work, especially that in the cloud providers, the Google cloud provider propagates these core addresses to the etc host of VMs.
So the only question I have is the main difference between ResolveConf and etc hosts is we've always done ResolveConf this way. If we suddenly start doing ResolveConf etc hosts this way, does it present a problem for people who aren't expecting it? Like, do we need to make this strictly opt-in?
I cannot think about such situations straight from the top of my head. If we skip all the localhost entries, I believe this should be safe. Most likely there will be some additional entries for the VM hostname itself, but I don't think it came with any risk.
Yeah, I don't know either. I think that's something to discuss in the CAP. If we turned it on by, the simplest thing would be to turn it on by default and everybody gets the fix. But here are the security considerations, and we need to solicit feedback from at least the other cloud providers to see if they have anything obvious that they can think of there, and the major on-prem providers like OpenShift, tends to have a very good security posture. So what would we need here?
Okay.
And if we need to make it opt-in, then we make it opt-in and we set the flag with the default of nothing and let cloud providers opt in by setting it to a value. But it seems consistent to me. Anybody else have concerns with this?
I got lost with one thing. So the original idea is to add an additional file with its host, and now this is to provide directly the file.
Yes, so Tim proposed to use directly the node's etc hosts.
So you can say, okay.
I mean, we already use the host's result.
Yeah, we are doing it without any flag. So you're saying now it's like we had this flag that was using its host, and now if you want, you can use another one. Oh, that's smart. I think that is much better. Okay. Well, time check. Any questions on this? This is a CAP, right, Marek?
Is it already a CAP or is it like pre-CAP?
No, it's a pre-CAP, so I'm asking for approval to make it a CAP.
Who is going to drive this? Because we usually have this mix with node and network.
I can
you
drive
used to
this.
navigate more these waters of Resolve.conf and all these things.
Yes, realistically, we need a reviewer approver from SIG Node. Practically, when it comes to these sorts of issues, they're going to mostly defer to us on the design, and they're just going to pay attention to the implementation.
But if there is no complaints, do we agree on following up with a cap? Okay, well, then now we need to hand over to Maciek team and give him host permissions. He's
Already
going to
done.
talk about
Maciej, you should be able to share.
multi-network plus DRA design. All yours, Maciek.
Yeah, I have some slides. All right, I think multi-network is good and alive, kicking, still kicking in some way. So I want to kind of show what we kind of for the last few months or even years probably came around, and what we would like to kind of move forward with. So basically, you can even see my slide. So to give you some context, why are we still looking at this and where we at? So I want to call out the Multus and some other implementation, but Multus is the most popular. That's why I'm kicking to that one. So the one kind of pain point with Multus, what we have today is it created an out of scope CRD, out of core CRD. And the way it integrates with Kubernetes, it's always via annotations, whether it's how you select the thing or how they provide the status. Then the other aspect that happens recently in the ecosystem is IML workloads coming around, right? This specialized kind of working towards as well as specialized networks, and then requiring those. And then additionally, we do still have the multi-network and multi-interfaces use cases that are relevant for Kubernetes, right? Like KubeVirt with VMs or physical separation of control and data plane traffic. I will have some more use cases later on. And then lastly, for the AIML stuff, we did come up with the array, right? Which nicely tries to handle resources for the pod. And it can very well tight and very well be combined as a core functionality for those pieces. So this is where kind of we are at, and that's why we are start looking at the array as well and how to integrate with this. From that, some questions come around, right? How does the integration looks like? And I'm hoping to kind of answer that in a few seconds. So what sort of use cases can we address with this? And then basically what are the future missing gaps, right? That we want to need to address. So that's some things we need to kind of answer. But before there, I would like to kind of call out what we want to do. So how we are positioning multi-network in relation to DRA, and how we are trying to kind of look at this is to kind of provide 3 separate, let's call them segments, areas, how this can be divided into. And the area A is basically your standard DRA APIs, where you just go use the selectors, and whatever you want to do, you just deal with DRA APIs to pass resources into the pod. So think of your AIML use cases, your other hardware-based. I just want to have a specific resource passed to my pod. Then we want to kind of call out a pod network area. And I'm going to talk about the pod network API later on. But for now, just here, just want to call out the section B, the segment B, where we just want to have a means to have an orchestration of common set of configuration for in this case, a networking aspect. So B, if you think about and you're familiar with DRA, is basically can be done with device class. And that's a fair point, where B is basically that, where device class can have the set of common parameters that can be put into device class, and then referencing the resource claim and be done with that, right? But we want to call out B to kind of provide the kind of phasing, and that's one aspect of when I'm gonna get to the section C. And then the other aspect for B is to cases where I still want to use pod network. Since I'm gonna use the pod network later on, I may want to maybe leverage the pod network definition rather than the device class. But yes, fair to say, if anyone would say that B can be handled by device classes, that is a true. And by the way, this kind of current effort that we're looking are focusing on B. And the phasing aspect is for that purpose to initially just define the pod network or some object that will reference or represent the network a pod connects to. And then lastly, the C section where segment where this is where we want to eventually get to the stage where we want the pod network be in the area where we can tightly connect with other Kubernetes primitives like services, network policies, and this is the area what we kind of looking forward to. We know today the one aspect of this is we require an object that represents a network to where I can apply those features onto. And those are like services or network policies. When you think about those features, they can either apply on today they apply just to the default network, the one that we have, because there is only one network, right? But in multi-networking environment, it's like in public clouds, you have your VPCs and you have your load balancers or firewalls specific to that specific VPC. So this is akin to this. And this is where the C segment kind of steps in, right? Where we can then build and try to look into integration of those capabilities into Kubernetes. And I'm going to show some use cases for that as well. Any questions to this? I'm going a bit fast because I have some demo as well, so I apologize if you, but interrupt me if there's any question. So what does that gives us, this separation? Allows for various developers to engage with the various complexity, right? So that's the main thing for those three areas, right? Then as you're gonna see later on, DRA is still the core user facing, the application developer facing API, and I'm gonna drill on that later on. And then lastly, we can provide and deal with separate progresses and the RSD around this area. Like for example, DRAnet deals with the
Maciek, I cannot hear you. Maciek?
Yeah, he went dead for me too.
Can you hear me okay now?
No, it's okay.
There you are.
Okay, sorry. So my headset just nobody's speaking, and okay. So yeah, the last basically allows us to separate focus on various areas, right? We have DRAnet that deals the downward stuff like NRIs, integration with directly with DRA, but then we here want to focus as well on the upper layer, right? Integration with the other DRA, the other Kubernetes native features, like for example services, right? So this is how that kind of the segmentation allows us to do that. And then the use cases that we want to kind of put into those three segments, right? We have the segment A, which is a strict the base that we currently handle for AML. You have an RDMA interface, you want to pass it to the pod, but this as well applies to not only RDMA interfaces, you want to have a just standard hardware-based interface into your pod. And you might not need any pod network for this. And that's where you're just gonna deal with your DRA, depending on the provider, specify the proper selectors and pass that to your pod. But then there is a section B, which I did mention we can be as well with device class, but pod network can be the orchestrator for configuration for some networks that I just want to attach to them, right? And I want to have a common way, and I want to use my pod network as my front end in that configuration. And then lastly, this is where the whole integration is, like I mentioned, like the VPC for pods or VMs case, right? And this is where the ultimate goal where we want to get to. And this is where we are seeing that we do need an object to represent that specific network, so that we can integrate those additional core features with integrate those additional features to the network's concept, right? So that's how kind of we're seeing those kind of use cases falling apart into those 3 segments that I called out. Any questions here?
I think I have a question potentially that had been asked before, but you seem to be using the multi-network, or how it's called, in the isolation use case as a primary network for the pod, right?
Yeah.
Did you figure out what to do with the kubelet probes?
So that's something that, no, not yet. And this is definitely a case where a situation of how to get there. And yeah, that's not only that. There's the probes. There is access to the API itself. If I were say, even if on the right side hand, you look at as a VPC, right? You have a pod that connects to just the specific network, and basically those are the things that we need to address still, right? I just want to phase those kind of discussion out, and maybe that has to not be done like that. That at least that's how I'm feeling about this, considering how long it take us to get just to kind of, can we have the pod network object first, right? And then let's build on top of
yeah,
that.
I guess I'm trying to figure out how to think about that for now as I'm listening forward. So I just imagine that the probes thing is solved, let's say, and you can use it like that.
No,
right?
it's not.
No,
That's right now. No, that's the thing, right? That's where no, it's not. And basically all those things has to be solved. And maybe,
right. So, but for now, do I imagine that these pods with multi-network as a primary network just don't use the probes, and like they don't need that? Like, what should I be thinking about right now? How it works?
so right now you need to look at this as I mentioned, I'm trying to focus on area B, right? Where I want to add additional interfaces into the pod.
Okay.
The area C is where we are heading towards. This is where we want to get to. And this is why I want to call out that we do need the pod network object. And I have next slide to kind of call it out as what it is. But I think here I just want to call out that those are the use cases what we are looking for in the future to kind of justify the need for the object itself.
Okay, but is there at least like a concept of a default versus secondary network there, or like should I think of them as totally equivalent?
I think that, not sure I fully understand the question, but long term, yes, definitely we want to ensure the networks should be equivalent. That's what we definitely want to get to. Right now they are not, to the pointers that you called out, right? Like the probers will not work on the additional network because it's not looked into. And that's a fair point. That's right now not there.
Yeah, okay, but well, if we imagine there is a way to like tell the kubelet on how to do that and how to reach those pods and whatever, I will be thinking right now about these different networks as if they're all the same, and like the primary network
Yes,
almost
then at that
exist.
point,
It's
yes.
just
In
one
the
of the
C
things.
section, this is where we want to get to. Yes, that's the point.
Yeah, good enough for me. Thank you.
Tim?
On that topic, we've gone around more or less from the beginning of Kubernetes about whether we should have a link local network that is just the kubelet to the pod that isn't connected to anything else. And we've dodged it for 10 years. I'm not a huge fan of Model C. You know that. We've talked about it 100 times. The only way I see us really getting around the probes problem with Model C is something where the kubelet knows how to get to the pod, not through the pod's network, right? Like, is it time to finally crack open that can of worms?
And that's a fair point. Yes. So this is where I think what's let me kind of lead to this is we want to introduce the pod network object, and I think the core thing of it is in CRD. And we want to build it outside of core as similar to what Gateway API does, where you can add it. And with the current approach and the DRA availability, this is completely non-impactful on the current existing clusters. And what you're calling out, that will be a great step to that, so that we can look at the probes not under angle to kind of support this case, but just to generalize it in such a way that, as you said, we don't have to probe the interface. We maybe can probe somehow, it differently, right? So what the pod network object is, it represents the network a pod can attach to. And this can mean, the network aspect can mean a lot, but basically this is the interface, right? So you attach to the pod. We want to have a representation what is what, right? Then this becomes a administrative resource that on a cluster scope to kind of keep the configuration governance. And then lastly, this is where the main thing here is to have a binding component for the Kubernetes primitives in the future looking stuff. Like I want to kind of have serviceability on a specific network, not on, or for example, network policy on a specific interface, right? I have an example here of how the object looks like. At the end of the presentation, I have a link to the PR. So I don't want to go through the spec. There's something that we can talk in the PR itself. But here, just kind of want to introduce the kind of concept of the pod network itself. Moving on to the DRA integration, and this is very straightforward. What we are thinking here is to ensure the DRA is still front and center the API that user uses. So they still use the create the resource claim as they would with the DRA, and then just reference that in the pod. So there is no new things added here. The only thing what we want to kind of add here is the pod network notation, right? And by the way, the name might be something a subject to change. So we can have that discussion in the PR. I think this is something that we selected like 2 years as a poll, and we all decided on the pod network, but it can change, right? We can discuss that. But still, what it boils down to is to have the keyword here defined so that the claim just says, I want to have pod network, let's say BlueNet, right? And then the cluster administrator provides those pod networks for us. And what we assume, the DRA driver takes that as an input. Those drivers that do want to support the pod network, it's not a mandatory thing. It's just if I want to support multi-network, right? Then I have to kind of take the pod network into an input. And what that means is, on a resource slice, we provide that attribute on one of the resources for the devices, right? And that's how it's kind of interconnects. I have another slide which is more complex and more detailed. So let me switch to that. I'm not sure whether that's big enough. What this one says is we have our pod, we have our resource claim. In the resource claim, we pointed to some generic class. And then lastly, we have our expression to say, okay, I have pod network with BlueNet, right? And I will get back to the status in a second. But before there, we have our pod network. And here I define that, okay, I want my pod network, all the interfaces with the name ENS224 of an interface on the node to be described and belong to the pod network BlueNet, right? This is being taken and understood by the DRA driver in the discovery phase, and that's being listed out as an attribute here. And what we want to, and then lastly, this is where I need to get back now to the status, because this is where the DRA driver would be required to provide the network data section. This is what Lionel introduced in the resource claim status, where we can provide a networking information about a resource we pass. So we would require the driver to provide that information. And then there is another aspect to this, because the resource claim in the status, the devices, this is just a list. So right now there was no way to link the specific resource to our pod network. So the other thing we would require is to provide a linkage to our pod network right here. The data is a row extension field that would basically say that, okay, this device belongs to this network, right? And then basically this will be part of the standardization, would be to provide the keywords here and in those two places so that we can then link everything together. The one I think aspect here is the driver prefix. If we get this merged in, I think at that point we would like to go to the DRA folks and put a pod network as a how they call them, standardized names. I think this is something that the DRA is working on. And then instead of us using the driver prefix here, the driver domain, that would use the standardized domains of, I don't know what it is. I think it's Kubernetes IO or something, right? But basically, this would be the next step for us as a first enhancements to move away from the driver specified path to the standardized from DRA. Any questions to this? I think I have four more minutes. I have a demo.
Maciej, the one question I have is, in your example C, you're replacing the default network with a custom network,
yes.
right? And I don't see exactly how you would represent that.
So this is where then it's not defined yet, but what I would envision this, your default network is part of the resource claim as well. So CNI is being disabled at this point.
So in such a cluster, every pod has to have a resource claim that specifies its own default network. Okay, please proceed.
Is it, sorry, can I, one extra question, if that's a list of networks that you then require everyone to ask for, which one will go to the pod status AP? The first one in the list or something?
No, you list
or
them
we
all,
are not
right?
using that field anymore.
You're referring to the pod IP?
Yeah.
So that's something that as well has to be defined. That's Nadia, a fair point,
Okay.
right? Because that's something that then, if we move towards that, because right now we are not looking at it, the case that that team called out, at that point we need to either define that one of the networks in the list has to have a annotation called, or annotation, maybe a flag in the selectors called IAM default, right? And then that means that for that interface, for that resource, I would populate that data, Nadia, for the pod, right?
Yeah, I mean, that's what we're...
Yeah, so that's something that would have to be solved as well at that point.
Yeah, I guess we're only asking these questions because the other part about how to use DRA makes total sense. If you're thinking about the secondary networks only, makes total sense, doable, I think. Yeah, so this is the main kind of problem that, and yeah.
And
maybe I wanted to add, I don't know if you're aware, there is like a Nova Kubernetes plugin where the network plugin where we implemented kind of a concept of primary networks, which is very like plugin specific, but that's why I'm like very familiar with all the problems that you will face. And there are some ways to like work around the services and network policies and whatever else. Yeah. So
this is where exactly what you're calling out, right? We want to standardize the integrations, right? You can see here, if I have a resource claim with the interface and link it to the network, right? This is how, for example, your endpoint slice controller can find those endpoints for a service, right? And link it to the specific interface and create a service out of it, right? So this is where this whole then kind of other things can build on top of, right?
Yeah, sure. I guess today is about DRA integration, more about like the whole multi-network conversation, what's default and what's not. So let's talk about that next time.
Okay. We have 1 minute. Should I go to the demo? Let me maybe quickly go over that. Cancel. What do you want to do? Window. Share this guy. Can you see my console? Yeah. So basically, what I'm using DRAnet as my example. I hack and slash it a bit. Slice. So right now I have some interfaces. You can see my screen, right? I have some interfaces discovered in the slice, and this is one of it, but basically doesn't have any pod network here. And I have another node that has the 256. And so basically this is standard DRAnet. What I can do now is apply my pod network, which is just what I showed you in that example where, okay, my pod network will belong on all the interfaces with ENS24. So let me apply that. And then I have my, this guy. So I have my blue network, which is ready. And then I can just show your resource slices, which basically my ines224 now has a new attribute, right? Very straightforward. And same here, the resource ines224 has the pod network here, and ines4 225 doesn't have it, right? So we listed that. And then we have the list test pod. We have a pod that calls out my interface pod network here, and it just basically says in attributes, give me pod network blue, and that's basically apply test pod. So that's running, and let me just maybe here a kubectl get resource claim dash OYAML. So what I want to show here is the status. So we have status for this, right, for the resource claim, and the driver did provided the interface. There is no IP assigned, so no IP this time, but basically we have this guy outputted plus the required pod network name, so to which one belongs. And basically that's the demo. Let me switch back quickly to the other. I don't think the last thing is what I have is just the links, right? The link to this presentation is in the minutes. And basically, please look at this PR here, leave your comments. It has all the details that I just showed you. And there are some links here for the demo I just showed. The API itself, the modified DRAnet, and I did create some small controller for the pod network for the readiness condition. Team?
Thanks for that. I think, building up to option C is obviously the huge gap, or model C. Between where we are in A, I think we can all see the jump. Between A and B, I think we can all see the jump. Between B and C, I think it's going to be very difficult to express that jump. So I think that's where your pitfall is going to be. Do you see this? Is pod network proposed as a standard or semi-standard CRD or as a built-in type?
No, as a CRD, as I mentioned, this is just a CRD.
Okay.
Same like gateway API does it, so we are following the same model, right? It's not part of the core at all. All of the repositories is in Kubernetes SIGs, and this is an add-on you might want to live with or don't.
I think that's right. And I'll say, I know we're out of time, so we should wrap up. I don't think I understand that status change you made, so maybe we should talk about that separately, just so I can understand.
So it's not, I'm just leveraging what Lionel added. Lionel
you added a data field.
Oh, okay, so the data field is there as well, and this is a row extended field which you can add any text there. Basically, I'm just saying that in this there should be a field with pod network name.
Okay, well let's take that separately because we should wrap up the call.
And it's called out in the PR if you want to. Please look at
I
that.
think it's a good follow-up for getting more in detail in the demo and all these mechanics. Much if you have time and people is not on vacation, it will be ideal to have another 30 minutes with the demo and you showing this field and the other field, because the visuals help a lot, at least to me. So, well, up to you. Well, thank you. We are over time, and it was really nice to meet you. And well, enjoy the summer. The ones that are in the North Hemisphere, of course. People in the South. Bye.